Good day, everyone, and welcome to NAV 316 in this midterm period, week 4, session 2. We are here to discuss this topic. So, the topic for today is to describe the procedures in creating the user chart, critical points, suitable route plan, validate, and tracking of contacts. Together with my Group 2 members, Decadet Pongoyan, Decadet Buenafe, Decadet Borgos, Decadet Cañete, Decadet Cogtas, Decadet Gasalatan, and Decadet Johnson. So the objectives of this lesson is to determine and familiarize the procedures in creating the user charts and route planning, critical points, suitable route plan, validate, and tracking of contacts. So the ACDIS overview. Electronic Chart Display and Information System, or ECDIS, is a geographic information system used for nautical navigation that complies with the International Maritime Organization, or IMO, regulations as an alternative to paper chart. Next is the user chart to be discussed by my fellow member.
Good day. I'm Bongguyan Francis GC, and I'm going to tackle about my topic is with this user chart. So a user chart is a file created using a special ECDIS graphic editor. Information from this file is superimposed on electronic chart display. So the user chart in the active area is called an active user chart. So the operation of the graphic editor, which is used for creating and editing user charts, is possible in the active area only. So therefore, that chart currently in the non-active area, or what we call non-active user chart, cannot be edited and is merely displayed on the ECDIS screen. Next, the mariner may need to create his own object in the chart, for example, symbol. So object with point geometry. Next is the sector. It is an object with point geometry with defined radius and bearings, such as military practice area or pilot boarding place. Next is the line. Object with linear geometry. And next is the area. Object with area geometry such as cushion area, fish bank, guard zone, and anchorage. And the text means character string located near a point or a long line. So that's all for my report, and thank you.
Now let's talk about critical points. Critical points is where we insert important comments, reminders, or tasks that needs to be done in a specific time and distance about the passage. The Critical Points tab folder enables the operator to create specific latitude or longitude positions on a route which are defined as critical points. So this picture is the Critical Points tab. This is where we can manipulate the specific latitude and longitude positions. A warning alert is generated when the own ship is in the proximity of each critical point on the route. The alert can be triggered by either specific distance or time. The Critical Points tab folder is divided into the following areas. We have the route and the critical point. The route area enables the currently monitored route displayed in the route name field to be saved and validated. In order for us to generate the critical points on the previously saved route, open the route plan from the route tab of the Edit Route sub-menu. After that, the selected route will appear on screen. To discuss the procedures on how to create critical points on a route, let's have Manuel Benafe.
Now for the procedure to create critical points on a route. First, move the cursor to the position on the route where you want the first critical position to be placed. As the cursor moves over the route, the letters Add CRTT are displayed below the crosshair. Second, click on the required position. A purple square is drawn at that position on the route, and the window shows the abbreviation CP1 with its LL coordinate. If the critical point level checkbox is ticked in the route display setting, the CP number is also shown on screen. So for the third procedure, to change a CP label from the default CP1, CP2, and etc., select the CP and click in the field to the right of the label. The screen keypad appears. Enter a label name using the keypad and click the keypad OK button. The label appears next to the selected CP if the label tick box is enabled in the route display setting. For the fourth procedure, to create more critical points, to continue to click on the required positions on the route. As each CP is created, the purple square of the previous CP is displayed in the same color as the route in the critical points window shows its CP label and LL position. To change the CP's position, move the cursor over the CP in the root. Hold down the left button and move the trackball. The CP can be moved either up or down, the length of the root, or away from the root. When the required CP position is shown on the screen, release the left button, or in the critical points tab, navigate to the CP using the navigation buttons. With the required CP label shown, click in the LL fields. A drop-down keypad appears, enabling you to select a position for the CP. And for the last step, to delete a critical point, in the critical points window, navigate to the CP to be deleted using the navigation button and click on the deleted button. The CP is removed from the screen and list. So here is a video for more information.
So let's start with what are critical points. So you can see here I have drawn an example of a route or a passage plan that is there on ECDIS, and then you can click on any part of the passage plan and select insert critical point here. The good thing about this is you can click or insert it at any point of the passage plan, but you can use the cursor, press and drag it and put it anywhere in the passage which is nearby. All right, so what are critical points? Critical points are where you insert comments about the passage, important, very essential comments. Example being call master, or standby engines, or 1 hour notice to the engine room, or it could be watch out for like a buoy or a recon or a shallow depth, anything that the officer or the bridge team want to insert during the passage, which the watchkeeper should take note of. Another way of doing that is you can actually go into the route plan and click on critical points, and you will see that it gives you a choice to insert a critical point from a distance and at a time from the next waypoint. So the distance refers to the distance from the next waypoint, and the time refers to the time of alteration from the next waypoint. So that is another way of inserting the critical point at your desired point in the passage. So if you want to, let's say, give 1 hour notice, say 3.3 nautical miles before the next alteration, so you can do that at exactly the point you want to. So you can insert the critical point at any point, right? Then once you do that, like I said, you can move it around, and then what you can do is, like I said, you can select it at the desired distance and time, and also insert a message here. So for example, I'm showing you here is that I have put call the captain here at 0700 hours. This is the message I wanted to put in the passage so that my officers read it and call me when it's time for them to call me, right? So once they come to that, I can also select the time and distance if I want to. So once we come to this point, then the officer on watch will call the master, and you can insert any critical point here. All right, so even if you select the critical point, you will get the information displayed. All right, now this critical point, like I said, you can insert it in any waypoint. It depends on your decision or your choice, but once you do, you can see here you can display the critical point as well. You can go and select on the critical point, and I'll show you how to get the information. So once you insert the critical point, if you click on it, you will see that the information regarding the critical point is included in the passage plan and waypoint here.
So hi, I am Ginson. So for today, I'm gonna discuss about suitable route planning. So route planning is used to decide the route to take from one place to another. So there are methods of route planning. So it represents like the shortest route, the quickest route, or the quickest route according to the traffic information. So passage planning or voyage planning is a procedure to develop a complete description of a vessel voyage from start to finish. Now it includes dock and harbor area, en route portion, approaching the destination, or the industry term for this is berth to berth. So next please. So in order to make a suitable route planning, there are 4 main stages in planning of a safe voyage. It includes appraisal, planning, execution, and monitoring. So appraisal is collecting and assessing all relevant information required for the intended passage, the collection of information and validation of all relevant information. And planning, developing and improving a passage plan based on the outcome of the appraisal of all relevant information, or the presentation of the raw data into formation and the strategy to use. Execution, briefing the bridge team on the passage plan, navigating the ship in accordance with the passage plan, or the execution of tracking, voyage, and communication control. Monitoring is checking progress of a ship against the passage plan, or like ensuring that the voyage plan is being followed. So next is Cadet Burgos will explain about the procedure in route planning.
Thank you, Cadet Johnson. So the procedures in route planning. So take note, that the system allows route planning in different ways. As for this case, I am referring with the application of radar GMA 900B ECDIS series. And so let us start. So first is to plan your route or route by using the table editor. So this is in line with as to find the information from all the nautical publications available within the coastal area. So next is while displaying current waypoints, graphically draw your next waypoint on the chart. Third is by editing the route is just as simple as inserting. So this is essential for us to clear out and maximize the safe navigation. Also, the dedicated menus are readily available to assist the mariner in effective route planning. This also applies even from the previous ECDIS models, which is using the standard CSV format. And lastly, you can add an alternative route, which can be displayed simultaneously. So here is a short clip in regards with our topic, which is the suitable route planning.
Most ECDIS systems can operate in two modes: route monitoring, route planning. An ECDIS system, when powered up, will normally automatically start in route monitoring mode and display its own ship's position on the chart. The following definitions of a route plan can be used in connection with ECDIS. A route plan is a description of how a voyage is to be carried out. The simplest version of a route plan consists of waypoints drawn in the chart. Straight lines, which show the intended sailing between points, connect the waypoints to each other. A waypoint is a position where the ship's course is to be changed. Waypoints can normally be inserted by pointing to the required position in the chart or typing in the actual latitude and longitude from the keyboard. The line connecting two waypoints is referred to as a leg.
Good day to each and everyone. I am Decadet Benz Odricanyete, and I am going to give the procedures on validating of contacts. So, validating. When validating a route on ECDIS, always consider ENC display settings, and as with paper, use the best scale. Also, take time to check and scan routes. It is advisable first to conduct automatic route checking, adjusting the route each time to correct the alerts generated. One should then manually scroll along the entire route to visually check for any hazards. We should bear in mind to have a patience, for it takes time to check a route properly. Remember potential limitations of route planning and checking on small-scale ENCs. So, the principle of good seamanship and maintaining a proper lookout apply when navigating electronically. Plan to use all available sources of information. So, safety settings should be adjusted throughout the voyage to reflect the demands of the situation. For example, when coastal navigating vectors, cross-track corridors, or XTC, and guard zones should all be reduced. Settings such as safety contours and safety depths should be set higher for ocean passages to provide early warning of landfall hazards or the possibility of increased traffic. Thank you so much. Let us proceed to the next reporter. She's Decadet Cecilieto Gasalatan.
Next is monitoring. First is that do not rely solely on automatic alarm. As for the saying, a prudent navigator should always seek to prove that ECDIS is wrong rather than assuming it is right or correct. Next is to use the tools such as the radar overlay or RIO to assist with the monitoring, because an accurate RIO provides a million point fix and allows an excellent real-time monitoring. But then again, do not solely rely upon it. Next is to cross-check frequently with the other systems. For example, Lawrency and manual means like visual and radar fixing. So next is to ensure that the appropriate display setting are applied for the coastal or ocean and day or night navigation. And lastly is to use profiles if the functionality exists. So that would be all for our discussion for today. Thank you for listening.